Okay, part A, the natural numbers, these are also called counting numbers, and they're numbers that you would use to count items. So 0 is not a counting number because you would never count 0 items. And you can count 1 item, 2 items, 3 items, and so on and so forth. So the counting numbers would be just 5, 17, and this because it reduces to 20. So part A would be 5, 17, and 40 over 2, which is actually 20. Okay, for the whole numbers, these are all of the counting numbers including 0. So the whole numbers are 0, 5, 17, and 40 over 2. That's 20. Part C, the integers, these are the negative and positive whole number values. So let's see, that would be negative 8. Negative root 5 is not 1, neither is 0.6, and then it would just be 0, 5, 17, and 40 over 2. Part D is the rational numbers. These are any numbers that can be expressed as a decimal or a fraction. So negative 8, negative 0.6, 0, 3/4, 5, 13 over 2, 17, and 40 over 2. And let's see, part E is the irrational numbers. Those are all the numbers that were not rational. So root 5, root 3, and pi. And finally, the real numbers, well, they're all real numbers. So all of them are real numbers. So let's see. Negative 8, negative root 5, negative 0.6, 0, 3/4, pi, 5, 13 over 2, 17, and 40 over 2. Okay, number 21, is every rational number an integer? This is false, because rational numbers include things like, say, 0.6 or 3/4. Those are rational numbers, but they're not integers. Okay? Number 23 is every irrational number an integer? No, an irrational number is any number that cannot be expressed as a fraction or a decimal. So integers can always be expressed as a fraction or a decimal. Like 5 is an integer that can be written as 5 over 1. Okay. Negative 4 is an integer that could be expressed as negative 4 over 1. So this is also false. Number 25, every natural number is a whole number. Well, natural numbers are the numbers from 1, 2, 3, blah, blah, blah. Whole numbers are the numbers 0, 1, 2, 3, blah, blah, blah. Every one of these guys belongs over there as well. The whole numbers have an additional element, the 0, but every one of these is also in there. So this is true. Number 27, some rational numbers are whole numbers. Sure. Any number that's like 5, that's a whole number. You could write this over 1, so that's a rational number. So this is true. Okay. The absolute value of any number is the same as the absolute value of its additive inverse. So for example, the absolute value of 5, is that equal to the absolute value of negative 5? That's the additive inverse of 5? Yes, because 5 is equal to 5. Is the absolute value of negative 3 equal to the absolute value of positive 3? Yes, that's true. So this is always true. Okay, for each one of these, we want to, for part A, give the additive inverse, which is just the opposite of that, and the absolute value, which is the positive version of that number. So the additive inverse of this would be negative 6, but the absolute value is always positive, so it's positive 6. Here the additive inverse is a positive 12, the absolute value is also positive 12. Here, the additive inverse is negative 6 over 5, but the absolute value is a positive 6 over 5. Okay, we're doing number 43. This portion here is positive 2, but then when we tack on that, we get negative 2. This portion here is a positive 4.5, but we tack on that and we get negative 4.5. This is a positive 2 plus a positive 3, which is 5. This is a positive 9 and then minus a positive 3, so that's a 6. This is a positive 1 plus a positive 2 minus a positive 3. Well, 1 plus 2 is 3, minus 3 is 0. Okay, we're writing an inequality symbol. Inequality symbols are like greater than, less than, or not equal to. Those are the inequality symbols. So 7 is greater than y. Number 69, 5 is greater than or equal to 5. Number 71, 3t minus 4 is less than or equal to 10. And number 75, 5x plus 3 is not equal to 0. Okay, we're just simply going to simplify and then decide whether each statement is true or not. So this side adds up to 10. So is negative 6 less than 10? Yes, we'll put true. Number 77. 2 times 5 is 10. Is this greater than or equal to 4 plus 6, which is 10? Well, 10 is equal to 10, so 10 must be greater than or equal to 10. So that's true. 79. This is a positive 3. We tack that on and we get negative 3. Is that greater than or equal to negative 3? Well, they're equal, so it is greater than or equal to. So that's true.